this presentation, we're going to cover a couple elements that you'll need to know to begin completing the labs in Geography 6350. We're going to learn how to download a data file off a Blackboard, how to set up your project folder. Once you set up your project folder, how to open GeoMedia Professional, make connections, do some data mining, and some other operations. So the first thing you'd want to do would be connect to the internet and log on to Blackboard. Once you have the landing page up, we're going to go to Learning Modules, left click on Learning Modules. That should open whatever modules are available for you. We're going to work in the GIS Demo module today, so left click on GIS Demo. And this should automatically open a download window. If you don't get the download pop-up, you probably are going to have to authorize the action. So once you get the download pop-up, I'm going to save as. And you're going to set up a folder on your C drive. So if you have Windows 7, most of you probably do, left click on the C drive, left click on the new folder option, and the naming convention for the folder would be your surname and whatever lab it is. We're going to call this one Lab 1, so Weinmiller LAB 01. And then we're going to double left click on the icon to open that, and then save the zipped data file into that. While that's downloading, just take a moment, I'll go ahead and left click to get a file folder open. Actually, let me show you how you would do that. From the virtual desktop, you would go up on Start Programs and open up the computer, then double left click on the C drive and go down and just open up your folder. And let's go ahead and give this a moment to download. Once the zip file is downloaded, we'll double left click to open up the compressed folder. One thing I need to explain is that this particular file that you've created up here, your surname Lab 1, should only be one folder deep. So all of your data should be available in that particular folder. There are two instances where that might not be. That would be if you're using an ArcView shapefile or an ArcInfo file. In those particular instances, you'll want to leave the folder intact with the shapefile and all of its contents inside. The same thing with ArcInfo. ArcInfo may have folders inside folders. So now we have the zipped file downloaded. So I'm going to pull up my folder again, double left click here. You'll notice that the GIS demo data is inside another folder. So I double left click to open that. I'm just going to left click to highlight all three items, right click, copy. Then I'm going to go up top here on the breadcrumbs, left click on Weinmiller Lab 1, left click down here, white space, right click, and paste those particular files in there. You notice there are three different kinds of files there. There's a .gws extension file. If your computer is set up to display those file extensions, you'll see that, but you can look at the icon. It's a blue G. That's a Intergraph GeoMedia Professional Geo Workspace. There's another icon that has a red key. That's a Microsoft Access database. And this is just a GeoTIFF image. We're not even going to use that. Once I have the data open and in my file in the correct place, only one layer inside, I'm going to right click on GIS Demo and delete that. So send that off to the recycle bin. And I'm going to just minimize this. I would recommend that for the first couple labs, as you get started on this, I would not close your Blackboard connection because the data that you've downloaded may be corrupt and you may have to download another incident of that and unzip it. So I just minimize that. Now we're going to open up GeoMedia, so we're going to go to Start, All Programs, scroll down to GeoMedia Professional, left click, and left click on the blue G for GeoMedia Professional. It should launch the software. And at this particular pop-up, we're going to select the radio button that says blank Geo Workspace by left clicking in there and click OK. Now, my desktop is a perfect world, so to speak, because I've already aligned everything. I like to see 2 rows of tools at the top, a row of tools to the left, and a row of tools to the right. If you have tools to the left, tools to the right when you open it up. I don't like to see 4 or 5 rows of tools up here, so these can be easily moved around by left clicking on this little vertical bar, left click and hold. Because we're recording this, we get that crazy tracks, and you'll notice we can move that around, and if we would want to refresh, we would probably get rid of that. Once you move everything around, my preference is to have the pointer toolbox right here. Actually, I would prefer have the lat 1 right next to that. So the location indicator. So what we're going to have to do here is pull this out of the way and then just left click and slide this over. It should go there. There you go. Enough of the rearranging. Then you'll notice that if you roll down here to the corner, you'll get a diagonal arrow, left click and hold, and you can pull that all the way down as well. So now you have all this white space, and that's why we have these nice widescreen monitors, is so we have a nice big palette to work on. The other thing you might want to do is if you roll between the left window and the right window and drag it over to the right a little bit to open it up. This is your legend, and this is your map window. This is where everything that you're visualizing, all the map objects or features, will be visualized in here, and this will be the control. The legend controls what is over in here. Now, about the tools, you have a toolbar up here that's basically a Windows style toolbar, and then we have some tools here as well. So this is the main toolbar, and then we have various toolbars that we can turn on and off if we wish. We have a magnifier, a zoom in, a zoom out, a zoom to nominal map scale. We'll get to that later in the course. A fit all, a pan, and a update all or refresh. So those are the basic tools we'll probably work with today. We're also going to work with analyses, warehouse, and legend. Now, if I left click on warehouse and roll down to connections, you'll notice in the connection windows there's nothing. So we have no connections. So we basically have this blank palette, which is a template, a Geo Workspace file with no data. So we're going to make a connection to a database. In this instance, it's going to be a Microsoft Access database. So we're going to left click on Warehouse, roll down to New Connection, left click. We're going to select the connection type. It's already highlighted because it's the first one alphabetically. It's Access, and we're going to connect to a Microsoft Access database. So that's where you would leave that go. And the connection name over here, we're going to change by left clicking right in front of the C, hold down my left click button, highlight connection, and I'm going to call this US sample. How do I know what to call it? Because I know what the database is, and you will as well. So you want to name your connections so that once you get to about 10 Microsoft Access connections here, and I'll show you in a minute how you can look at how many connections are open again. You'll want them named so you have an idea what's in all of those. If we were going to do a ARC info connection, we'd click this, an ARC view here. You can see there are quite a few different kinds of databases that GeoMedia works with. Next thing we do, we have to tell the computer where the connection is, where the Microsoft Access database is. We'll left click on the Browse button. Now, GeoMedia has 2 default folders that it sets up when it installs on a computer. C Warehouses and C Geo Workspaces. They're both on the C drive, a folder, and inside there are Warehouses and Geo Workspaces. But that's not where we want to go. We want to go to the folder that you set up and downloaded the data into. So left click on the drop down window, left click on the C drive, scroll down, double left click on your folder, highlight by left clicking US sample MDB, and left click open. So now you'll notice, and here is the file path, C:\Weinmiller-Lab1 US sample data.mdb. The reason I have you set your data up or download and work in a folder on the C drive is that if you store all the data in there, save everything into there, what will happen is you will be able to, I've got a little warning here, you will be able to actually save out all of those data at the end of your session, zip that up and send it to me, and it'll work perfectly on any computer in any C drive that has this software. In addition to that, you can move your data around, work in your geo workspaces, work in your GIS projects from the lab on AUM's campus to your home computer. So that's why we set up these files. So we're pretty sure everything's okay. Let's click OK. And now, how do we know that the connection's made? Left click on Warehouse at the top, scroll down to Connections, left click, and you'll notice that here we have a connection now. Access US sample is the name of it. Its type is access, and there's the file path that it's at. So close that up. We have one. Now what we're going to do is we're going to do a little bit of data mining, and we're going to output the data that we mine out of US sample into a new Microsoft Access database. So we're going to create a new Microsoft Access database, and when we do that, we'll have an automatic connection to that database. By the way, you don't want to create Microsoft Access databases in Access. You can do that. If you do that, all of the tables that dynamically link the relational databases together within Microsoft Access don't work, aren't there. So if you create a Microsoft Access database, always do it in the GIS environment. That would be for Intergraph, GeoMedia Professional, as well as Esri ArcMap. So we're going to go up to Warehouse and left click again, roll down to New Warehouse, the first option, left click. This particular screen just asks us, you'll notice there is a MDT file extension here. That's a Microsoft database template. So it's asking us what kind of template we want to use. And we don't do anything here as far as moving around in the file structure. We just say, take the default normal Microsoft Access database template by left clicking on the New button. Now, it's asking us, what do we want to name this and where do we want to save it? Here's where we have to go back to our folder. So left click on the drop down window. It went to the default. Go to the C drive, scroll down to your folder, double left click, and we're going to call this particular Microsoft Access database Alabama. So A-L-A-B-A-M-A. I think that's the way it's spelled. And click Save. So let's go up and take a look and see what we have now. Warehouse connections. We have Microsoft Access Database, US Sample, and Alabama. So let's close this a minute. And let's left click on Warehouse, go down to Feature Class Definition, and left click. I'm just showing you that if we can actually drag this down a little bit to extend that window, you'll notice that Alabama has no plus here, but Access US Sample does. If you left click on the plus, these are all the features that are inside that particular database. A point feature for cities, polygon counties, point highway interchange, 2 line features, interstates and rivers, another point feature for route shield, and if I showed you that, it actually has a unique symbology. A text feature for state name labels, a polygon for states, and an image for US sample image. GeoMedia used to, in some of the earlier versions, not treat images as features. Nowadays, they're features. So the 3 basic kinds of features in the vector format that we're going to be dealing with in this particular course are points, polygons, and lines. or points, areas, and lines. Any way you want to say that. Text, I don't consider to be a feature that we're dealing with topologically. We do that, and images are something else as well. So you'll notice Alabama has no features, so we'll collapse this again and close it. Now what we're going to do is we're going to do two attribute queries. And I want to make the point here that a GIS does not work by looking at this map window. It could care less what's in that map window. It is working through relational databases and actually working through topological tables. So it works at the table level, not beyond that. This geo workspace you're looking at right now is the template, and the warehouses are the data. GeoMedia and any GIS software doesn't deal with the visual. It deals with the flat file tables only. So we're going to do some queries, not display them in here so that you can see. This is the example that I use to demonstrate that GeoMedia doesn't have to see anything to accomplish a task. So we still don't have anything in this map window, although we have data that we could, if we left-clicked on legend, add legend entries, we could actually add a legend entry, which would be over here, and turn on and off map features here. So let's go to analysis. We're going to do an attribute query. So left-click on the attribute query. Now, right here, the blue indicates that there's a question to be answered. So we left-click on the drop-down. There's no features in Alabama. We're querying a feature now for a particular attribute. So we left-click on the plus, and let's highlight counties by left-clicking. Now, GIS has features and attributes. Features are the map objects. They have geometry. Attributes are basically information, aspatial data about map objects or features. Can be a variety of things. With counties, it could be county name, it could be the population, it could be the area. So there's lots of information about counties, average temperature, average snowfall, average rainfall, whatever. And in order to determine what attributes are in the counties table, this is the counties table, left click on the filter, and now we're in this filter window where we're going to begin to build a SQL statement to query out exactly what we want. Now what we're after is, because we set up a Microsoft Access database named Alabama, we're going to query out all the counties where the state name is Alabama. So we're going to counties filter where, we're going to scroll down to state name, left click once to highlight it, left click on the black down arrow, and it'll put it down in the query window. Now you could double left click on state name and it popped down there, but I prefer to work the slow methodical way. These are operators. Equals, if we left click one time, not twice, because it'll put it down there twice. It automatically pops down there. So far our statement says, show me counties where state name equals, and we want to show values by left clicking on the button. You'll get this warning, just take the default and say yes. It's just telling you that if there's 2,500,000 records in there, it's going to take a long time to go through there and pick out perhaps 250,000 values, different unique values. So right here's Alabama. I left click to highlight and move it down there. So here's my SQL statement. Show me all counties where state name is equal to Alabama. We could also extend this and say, or show me all counties where state name is Georgia if we wanted Alabama and Georgia, but we don't want that right now. Why do I show values? Why don't I just type Alabama? This is case sensitive. So without looking at the database, I don't know whether Alabama is spelled with all uppercase or whether it's spelled with a single uppercase at the first character and then all lowercase or all lowercase or whatever. So in order to make sure that I get it right, because this is case sensitive, I show values. And if in fact you made a mistake, put all uppercase in there and did the query, if it is first character uppercase, rest of it lowercase, it would turn up no incidence of it. So this is all correct. We're going to click OK. And this checkbox here says display the query in the map window. We're going to take the check out of there. Display query in the data window. We'll take the check out of there. No, I think I'll leave that there and we'll click OK. We're not going to have anything in the map window, but it's going to pop up a data window. So click OK. There's all 67 Alabama counties. So you can see they're there. We'll close that data window. Still have nothing in the map window. Now what we're going to do is query out again, analysis, attribute query. This time, left click the drop down. Let's go to states and we're going to filter, go down again, and I'll double left click on state name for you. It pops down there. Left click once for equals, show values. Yes. Remember, we have to show the values. I don't know that if Alabama is spelled exactly the same, using the same upper and lower case in the state name or in the states table as it was in the counties table. So I double left click Alabama and it's down there, and I'm going to click OK. We'll leave this. Once you put a checkbox, as long as you haven't closed your Geo workspace, all of these parameters will stay the same. We'll leave that check in the box and click OK. There should only be one county or one state with the name Alabama, and there it is. And by the way, these are all the attributes in that table. So still we have nothing up here. But if we go to analysis queries, you'll notice that there are two queries in the queries window. And if we went for properties and left click on that button, we can actually look at the properties. This is attribute query of states, and it's the states table, and it says state name equals Alabama. We'll cancel that and close that so you can actually look at your query. Now what we're going to do, we still have nothing visible in the map window. We're going to output these features to a feature class. A query is just that. It's a query. It's not a permanent feature class in a database. In order to get it into the database, in GeoMedia, we output the feature as a feature class. So what we're going to do is go up to Warehouse on the main menu bar, and we're going to roll down to Output to Feature Classes and left click. Now, you've seen a window that looks similar to this. It was Warehouse Feature Class Definition. Here we're looking at everywhere that there's a possibility of having something that either is a feature or could be a feature. Let's take a look at this. If we click the plus on queries, there's your two queries. They're still queries, question mark. So they don't have an icon. If we left click here, there's cities. Notice these have the icon for the feature class that they are. So what we're going to do is look at this one more time. If I put a check here, it checks everything in there. You'll have lots of queries, so you won't want to do that all the time. You can just check them individually. If it's everything, it'll default there. Let's look here on the General tab. Target Connection Alabama. GeoMedia has some inherent logic. So it's making the assumption that you are going to output the features not into the same database that you mine them out of. You're going to output them into an empty database. Makes sense. So it assumes you're going to use Alabama. But check this. Now, this is the name of the query. If we left click on the Advanced tab and we look at the target feature class, you'll notice that the target feature class name would be attribute query of counties. That's not a very descriptive name. As a matter of fact, I don't like it at all. So I'm going to left click once, left click again, and roll and hold and highlight everything that says attribute query of, and I'm going to type Alabama. So it's Alabama underscore counties, brings up a point. In a feature class name or on attribute, you cannot have either spaces or operators. Operators are anything that tell the computer to do something. So asterisk for multiply, minus or dash sign for minus, forward slash for divide, dollar signs, percent signs, anything like it, can't have it. Can't have a space. If you want a feature class that is 2 words, you use the underscore. Under attribute query of states, I'm just going to left click, turn it all blue, and type Alabama. Because that's basically a state boundary. We can fill it. Okay, here's a check that says display target feature classes in map window. Leave that in there, left click OK. It says the output process will result in 2 feature classes, new mode. Do you want to continue? If you don't get this message, something's wrong. Click yes. There you go. Output complete. Click OK. And now we have some features in here. We can turn these on and off by left clicking and by right clicking, I'm sorry. Right clicking, display off. Right click, display on. Now, a couple things about cartographic principles. Don't ever have boundaries that are green. So if we double left click here, this is the symbol, legend symbol. This is legend title or entry. If we double left click right here, it'll open up the legend entry properties. Right here, we have the boundary color. Left click once. Let's change this to black or dark blue. And let's go ahead and put a fill in there by putting a check in the fill box and leave it gray for now. And if you want to see what it'll look like before you accept it, left click the apply button. There it is. Click OK. I'm good with that. Let's double left click on the symbol for Alabama. Let's put a fill in there. This time let's make it this tan or brown color. And we're going to make the boundary dark blue. Okay, apply. Okay, you'll notice you couldn't see that because there's a hierarchy here. It's covered by Alabama counties. If you left click and hold on Alabama counties and drag it down, you see that blue bar? Let go. There's Alabama. Now you'll notice the hierarchy too. You notice this is turning green. And if I left click once on that, now it is highlighted green. That's one of the reasons why you don't want features to be green boundaries. Now if I double left click, it's going to give me this option because there's some stuff in there, other things it's picking out below. There's all the attributes for the state of Alabama. They are in the states table. So they are derived from the states table in US sample database and were output with that during the query and then output as a feature class. Basically, these rows are columns in the table. How do I know that? I'm going to cancel this. I'm going to go up to Window and go down to New Data Window. Left click, go to Alabama, and we'll go Alabama. OK. And basically what you were looking at was the reverse of this. These are all the attributes in that table. So let's close that up again. Now, another feature. If you want to see through this particular fill and look at whatever's below it, you can double left click and we can assign a translucency. Let's do about 65% by typing in a box, apply, OK. Now you notice we can see through and actually see the counties. However, we still have this hierarchy in place wherein if we select this, we're going to get the state again. We can't get to the counties. How can we fix that? We can do two things. We can right click on this particular symbol, go down here to locatable off, and left click. You notice the arrows going now. So now, even though the state is still on the top, look what's happening. I'm into the counties. There's Montgomery County with everything that's in that table. So locatable. Let's go ahead and turn locatable back on. Now you'll notice that the state highlights. But we can also just display off. The state's turned off, and now we're at the county level. Or we can just left click, drag it down, and display on and let it on. We can't get to the table. Now, we might like to label these counties if you don't know the geographic location of all the 67 counties or the names. And by the way, 67, that's all the counties. So that's the number of features in that database. We're going to insert label. This is the insert label window. Label features in. Left click on the drop down. Don't go by mistake to US sample because we could actually click the counties there. But if you click counties there and label them, all the counties for all counties in all states, over 3,000 of them in the United States, will appear out here in this white space, including Alabama. We want to go to Alabama and left click on Alabama counties. Now, what are we going to label? We certainly don't want to label annual rain or anything like that. So we're going to go to county name, left click. You notice everything lit up over here now. Some choices on placement. We could place it at an angle. Why do that? Leave it at 0. Alignment, center, center, means that it actually will put a text node in the center of the text and will center it in this polygon over here. We want to leave it like that. Let's go ahead, leave it as a query. Queries, the labels individually cannot be moved. So if you run into an instance where you have a L-shaped area, and how labels are placed is if it's center to center, you actually places the text node at the centroid of the area. In a state like Florida, if we were doing states, which is L-shaped, the centroid of that area is almost out in the Gulf of Mexico. So keep that in mind. You might want to change it to a feature class. You have to make some other decisions like what do you want to name it? And then you can move individual labels. But queries, the labels can't be moved. They're not permanent. But we'll leave it like that for now. We'll just say labels of Alabama counties. Left click down here on the style. And once, give it a little time to open up. This is the font. If I left click there, I can type Times New Roman and get to it pretty quickly. And let's make it about 8 point. Leave the color black. Left click on the bold. So there's what it's going to look like. Click OK and click OK. There's your counties. Now, the names you notice are a little large. They're outside. As you zoom in, the name's going to stay the fixed size and the county's going to get larger as you zoom in. And that would take care of that. But this is sort of like the fit screen. And I'm not so happy with that. So what we're going to do is double left click on that again. And we're going to just pop this down to 7. You notice it changed. Apply and OK. Looks a little bit better. Okay, so now we have those county labels in there. Next thing we're going to do is this is not a map until it has a north arrow and a scale bar. So under View, we want to put a check in north arrow. There it is right there. And View again, check in scale bar. Here's a problem. There's the scale bar. Normally I like them over here under the feature in the center. These are features. These are not. So these you left click and you roll them around ever how you want. The problem here is this is in kilometers. The units we use for distance in the United States are English units, so we want to get this to miles. Double left click on it. You'll get the scale bar properties. Under intervals and units tab, left click there. And you'll notice here the interval unit was kilometers. Let's click here and change to MI for miles. And right there it is. Let's click style. And single block with center line, I like a little color. Double block. Now we have major fill of red. That's what it's going to look like. Click OK. And now we have a scale bar that's in the proper units for the Western Hemisphere, at least, or part of it. This is a nice little north arrow, but let's double left click and I can show you that we can change that. We have some options. You can go to 14 there. There's some arrows. Oof, that's ugly. That's not so bad. We change the size a little bit, go down to about 60. Okay, there it is. And you can left click and you move that bad boy all over the place. Now, a little bit about zooming. Left click on the zoom out and left click on the center, left click on the center. You'll notice that, as I said, text stays fixed, but the feature itself gets smaller. If you right click, you'll get out of the mode. If you want to get this back on full screen, left click on fit all, it's right there. Let's go back out once. And I'll show you another one. Remember, right click, left click on the zoom in. And if you want to position this, I just draw boxes. Left click and hold, draw the box. And I want to put my scale bar underneath it. So that's about it. And this will center it in the window. That's not bad. Right click, left click, hold, and I'll pull it over like that. Now, as long as you don't hit click fit all, you're in good shape. So this is positioned properly. The reason it's kind of positioned to with the northern part to the left, southern part to the right, is the projection. So let's take a look at the projection. View, Geo Workspace Coordinate System. It is now a projection. The projection space is Albers equal area. Projection basically in cartography is how we take a 3D object and place it in a 2D environment and preserve some characteristic of the objects or elements that are on its surface. So with projections in geography, in cartography, you can preserve either area, shape, distance, or direction. Some of them, but not all of them. So depending on your projection, you're going to preserve one or the other. Albers equal area, as you might imagine, preserves area. The geographic space, the datum is WGS84. That's a popular one worldwide. There's lots of options on there, but we'll leave it right at WGS84. Units and Formats tab tells us what units and formats we're measuring in. Let's go down to distance, highlight that, and it's in units of meters. We're going to go to miles, and let's do a precision of thousandths by fixing that and click OK. The reason we're doing this is going to make some measurements here. Let's go to Tools, Measure Distance or Area, and left click. This is your Measure Distance tool. And you can change the units. That's the same screen you were at under View Geo Workspace Coordinate System, but we'll leave that go. We're still in miles. I'm going to left click right here at Pickens and Sumter at the border. You see that icon that pops up? The sort of valley and a mountain with a dot on top of it? That means that it's intuitively snapped to the node, which is the connecting point between those two counties. We'll left click once, it's attached. As we move across, let's go to Lee and Chambers, and we should get that icon. Left click. That mileage across there is 186,000 or 186.668 miles across there. If we scroll up to the corner, that leg, oops, is the next distance we see, 158.266. And if we scroll across there, and you'll notice that's 145.530. The total distance we've gone is 490.464 miles. It wasn't that fun. Hit escape and you're out of there. So that's how you measure distance. You can do it in meters, kilometers, lots of different ways. If you want to know the information about a county, just double left click on it. Here's some information. Generally, the area of that county is meters in meters squared, this humongous number. So let's fix that. Cancel. Let's go in to View, Geo Workspace Coordinate System, Units and Formats. Under Area, there's meters squared. Let's go down to miles squared, and let's give us a precision of thousandths again. And OK. Now let's double left click. Oops. Double left click along Montgomery and go to the General tab, and now it's calculated the area at 793.620 miles squared. If we go to Attributes, 793.1, this is what's recorded in the database. For making mathematical calculations, you can use either of these to calculate it. So let's cancel that. Good deal. Now we're going to do, and you'll notice that I've kind of slipped down into my scale bar. I can left click on the pan, left click and hold, and get it back up there. Right click to get out of there. Now, the projection that actually is best for Alabama for squaring it up is Universal Transverse Mercator 16, because the central meridian for UTM Zone 16 runs right through the center of the state. I want you to notice up in here, you see this? This is longitude and latitude, real time. As I roll around the window, you'll notice that changes. That's the longitude and latitude of the location of where you are in this virtual world you've built. Okay, we're going to do a thematic, and then we're going to do a query to test a hypothesis. My hypothesis is that Hispanic people like to live in rainier counties. That doesn't make any sense, but that's the hypothesis we're going to test. In order to do that, we have to plot average annual rainfall. by county, and then we have to look for the counties with the highest populations of Hispanic folks. We can do both of those with this database. To do a thematic, left click on legend, and we're going to add a thematic legend entry. Left click. Okay, what do we want to look at? Well, it's defaulting to cities. You want to, number one, get into your warehouse with your data, Alabama counties, and left click. We're going to do a range thematic, means we're going to go from the low to the high. And the attribute we're going to classify is annual rain, right there. Left click to highlight it. Let's left click on base style and get rid of that green. That's not going to look good. So click OK. And then left click on the classify. We're going to use equal count. Equal count will take the number of counties and the number of classes and divide them up. We have 4 ranges. I'm going to go down to 10. I don't think it'll give us that many. Here's the beginning value and the ending value. Click OK. It only gave us 4 ranges because there's just not enough data there to get into 10. So let's leave it at that. And let's go ahead and make this look like something that makes sense. Brown to yellow doesn't make sense when we're talking about rainfall. So let's double left click on this particular box, the low value, left click on the fill, and let's make it a light blue. Let's double left click on the high value, left click on that box, and make it a darker blue. Okay, makes sense, doesn't it? Light to dark. Ramp the colors by right clicking, left click ramp colors, and click OK. There's your map by rainfall. Okay, if you want to see the labels for the counties, just left click and hold and push it up to the top and let go. There's your county labels. A little bit more difficult to see because of the colors, so this is left click on here. And let's make them this ugly color right here. Now you can see them a little bit better, but not so good, but that's okay. Okay, so we have the average annual rainfall. Now, see this says Alabama counties. If I double left click in there, I can put rainfall in there. I haven't changed anything other than now it makes sense to me. And you haven't changed the feature class or anything like that. Next thing we're going to do now is we're going to query out some counties with high population values for Hispanic folks. So in order to do that, we're going to go back to the same kind of query we did to get Alabama counties out of US sample. Go to Analysis, Attribute Query. Let's go down here into Alabama, and let's go to Alabama counties and filter it. Filter gives us the attributes about the feature. And HISPOP is Hispanic population. Right there it is. So left click and put it down there. Now we're going to use the greater than or equal to operator. Left click once. Left click on show values. Yes, that just tells us big databases have big times. And let's go above 1,000. So equal to 1,152 or greater. So what this is going to do, this query is going to result in a feature, sort of, that has a Hispanic population. So it'll be a county feature. It'll have that geometry with Hispanic population greater than or equal to 1,152. Let's click OK. Now, we're not going to display this in the data window. That's the leftover from before. We're going to display it in the map window. And you see the style here? Left click on that. Left click in the fill area. And then we're going to go to Properties. And we'll leave the fill gray, it doesn't matter. Left click on Properties. Now here we have a decision. Simple line style would be the border of the county where that fits the parameter of the query, and we'll leave that go. Now if we highlight simple fill style, you notice the color is gray. Let's make it red, the same color as the other. And then it's going to be solid. We don't want to do that. We want to see through it. And see what the value for the average annual rainfall is. So left click on that, and let's do a backward diagonal. So that's what it's going to look like. You can see through it and see the color below. Click OK. Here's your last shot at looking at this. We could also assign a translucency, but I see no point in that. Click OK. And let's go ahead, and you see this his pop greater than or equal to. I highlighted that and I hit Control C, so I copied it. And I'm going to just get everything off of here and Control V. So the name of my query is going to be his pop greater than or equal to 1152, which will appear in the legend here. Display, everything's set, click OK. There's your counties where the Hispanic population is greater than or equal to 1,152 souls. For when, I'm not certain. Intergraph gives us this database. I think it's 2000 census. It might be 2007. It might be 2007 estimates or 2010 actual. We don't know. Well, what about my hypothesis? Weak evidence. But anyways, it was fun doing this. Now, you've done a lot of work in here. Let's go ahead and do one other operation. We're going to do warehouse. And we're going to do, let's go to connections. Let's do something like close US sample. And it didn't affect anything in your map window. So that means that there's nothing that is in this map window that is dependent upon that. Let's go to warehouse, connections, and we'll open that back up. Open connection. Now what I'm going to do quickly is show you how to do a thematic legend entry on cities in Alabama. So what we're going to have to do first is we're going to have to do analysis. We're going to attribute query. We're going to go to US sample, click cities, filter, and we're going to go down to where state name equal show values. I'm doing this pretty quickly. Alabama, put it down there, click OK. And I'm just going to type query of cities to label this, and I'm just going to put Alabama because I'm going to do a thematic based on the query itself. So I don't want to display the map window again, but let's just take a look at the data window to see what we get for a return. There they are, 72 of them, 72 cities in Alabama, and you'll notice they all have Alabama after them. So things are working out pretty good so far. These are the attributes for those cities. So a row or tuple is per feature. All these dots would be on this map if we would have displayed it. Now what we're going to do is a thematic map. So we're going to go legend, add thematic legend entry, and this time we're going to click down, go to queries, and we're going to go to query of cities, Alabama. Let's do a range thematic. Let's do attribute for classification. Let's do hispop again. Classify. Let's do equal count, which will give us ever how many, divide up the number of features. Let's do 10. See if it'll go 0 to 1882. We got some range value here, and there's the count. Let's go ahead and double left click on this, and let's put a that color in there for low value, sort of a pinkish color, and 5 will be good. Let's go down to the large value. I'll have to scroll down here. And let's go to the fill again, and let's put this dark color. But this time we're going to change the size of that dot to 24. Let's make it even 28. So it's larger. Click OK. So now we have small dot to large dot and light pink to dark pink. We can right click out here in the white space. We're going to ramp the colors, right click, ramp sizes. Now we're going to get different size dots representing different values of classes of population. Click OK. And there we have a map that shows the cities and the relative Hispanic population in those cities. So it's quite an interesting map. Now what we'd want to do is we want to save this before you close it. So go to File, Save GeoWorkspace. It's going to default to the Geo Workspaces folder on the C drive, one of the two default folders. Actually, it's on my D drive on this computer. That GeoMedia sets up when it's originally installed. Left click on the C drive, go down to your folder, double left click, and let's name this Weinmiller Lab 01. We're playing its Lab 1. Save. Now, to show you that your work is saved, we can actually close this by just closing it. We're going to go back to our folder. You notice Weinmiller Lab 1. There's Alabama. And by the way, let's just take a look at this. Let's double left click to open this. And if you look in the access, here's Alabama counties. There's the table we created. All of these other tables, with the exception of Alabama, should be one entry, one line there, are tables that GeoMedia created to preserve the topological nature of the database and all the dynamic kinds of geometry that are required. Okay, let's double left click on Weinmiller Lab 1 and see what happens. It should open to the exact view we had before. Okay, very good. So we're going to close that again, made no changes. Now what we're going to do is go back in a breadcrumb and prepare this to send to me. So here's how I would send it to me. You right click on the folder and you go send to compressed zipped folder. It's going to create a zip folder. In your computer, it may say you can't save it on the C drive. Can I save it to the desktop? And you say, okay, save it to the desktop. Here is the folder. You're going to go into Blackboard, go to Mail. You're going to go to Create Message, left click to Terrence Weinmiller, move me over there. You're going to give it a subject, Lab 01. Scroll down. You have to type something here. Hi, how are you? Here's my lab, whatever. Upload attachment. Browse. Mine's in the C drive, all the way to the bottom probably. There it is, Weinmiller. Open. You notice it's attached. Submit. And it's probably sending it. It's taking a while because, see, it's taking a while because there's an image on there. Once that's completed, you could actually go back and open it up in your sent mail. And what I would do was I would download your zip file, double left click on it, put the folder on the C drive. So that's how we do that. And we're going to close all these tabs. And that probably didn't send. So that's the end of this lab.